9, 8, 7, 6, 5, 4, 3, 2, 1.
Your chamber pressure is nominal.
T-plus 43 seconds into the test flight of the inaugural Starship vehicle. Tower clear to land a pitch over. Propulsion reports first stage engines nominal. What a sight from the ground cameras at Starbase. We're flying at twice the thrust of the Saturn V heading to space.
We're heading downrange over the desert.
Acquisition of signal, surface proceed.
We're throttled down and throttled back up. Going through the period of maximum aerodynamic pressure. And that call out tells us Starship is through the period of greatest stress. Velocity increases. The density of the atmosphere is decreasing.
Max Q.
Let's make stress on the vehicle. The call out, max Q now.
Seconds from now.
To get ready, the booster will shut down all but 3 of the Raptor engines. Plants holding the 2 stages together. Continuing to watch the first stage as we get downrange.
Starship will then separate from the Super Heavy booster and head to space. And at the same time, the 3 engines
100 seconds into flight.
Super Heavy will flip the booster around.
Our next major activity is going to be shutdown of the first stage.
On path.
Houston tracking station now acquiring the vehicle. With shutdown, we will get separation of Starship from Super Heavy and ignition of the Starship engines. When Starship separates, we light up 6 engines in a staggered sequence. If all goes well, those 6 engines will burn for almost 6.5 minutes. Onboard view from Starship. And there's views of the Raptor engines on the second stage as we prepare for stage separation.
Down the first stage
and after stage separation, the first stage will flip and begin a boost back maneuver for landing in the Gulf.
And acquisition of signal Houston and New Orleans.
Continuing to fly, 2 minutes 40 seconds. Let's get ready for main engine cutoff.
Booster engine cutoff.
Beginning the flip for stage separation.
We're hearing the cheering. The first ever successful hot stage for SpaceX's Starship.
Incredible views of our Super Heavy booster. And as you can see, the Super Heavy booster has just experienced a rapid, unscheduled disassembly. However, our ship is still underway with all 6.
Power and telemetry nominal.
And we just heard there, ship avionics, power
Kate,
and telemetry
right now
nominal.
it looks
All
like
6
we
engines
saw
are
the
lit,
start
as
of
you
the
can
flip,
see from the
but
GUI
obviously
there
we're
at the
seeing from the
bottom
ground
right-hand
cameras
side of your screen.
the entire Starship stack continuing to rotate. We should have had separation by now.
Now,
Obviously,
we did
this
know
is,
that
does not appear to be a nominal
the
situation.
hot staging was going to be incredibly dynamic, but we knew that there was a chance that the booster would not survive. But we're going to take that data and figure out how we can make the booster better for the next hot stage.
Yeah, that hot staging for
There.
the booster. And of course, it flipped around and had all this dynamic stuff happening. But ship is still going strong.
And it's doing great. Right now, the ship, the second stage, is on its way. As like we said, you can see all 6 of its engines are ignited. The next major milestone for the ship will be the shutdown of those engines, or SECO, second engine cutoff, which if you follow our Falcon 9 launches, familiar terminology there. So far, today has been incredibly successful, even with the RUD of the Super Heavy booster. This is amazing.
primary objective of the booster today, to get to hot staging, to get ship on its way to orbit. It did that admirably.
Yeah, we definitely asked.
Starship trajectory nominal.
All right, great news there. That trajectory for ship is
Acquisition of
nominal.
signal, Cape Canaveral.
Once again, Starship's second stage is firing those engines. And as you just heard, everything's looking good. Now, for the ship, we wanted it to survive hot staging, which, as you can see there by that little dot on your screen, it did. We also want to basically demonstrate that successful startup of those engines, demonstrating controlled ascent, which is what it's doing right now, and eventually orbital insertion. We are hoping to basically send this around the Earth, and if it makes it this far, splash down in the Pacific Ocean, a couple hundred miles north of Hawaii. Now, if we get that far, like, all of that sounds great. Secondary objectives for ship, again, continuing to gather engine data and about its health, performance.
Nominal ship chamber pressures.
Great news there. That tells us that the chamber pressures inside of the Starship, again, that's that small dot on your screen, basically the propellant pressures in the ship are looking good.
Yeah, the bottom right corner of your screen, you can see essentially a user interface showing us which engines are lit. So the 3 center sea level Raptor engines on ship are gimbaling engines. The 3 outer engines in the triangle, the larger ones, are Raptor vacuum engines. All of them continuing to fire nominally. So they're at the pressures that we expect to try to get into our target trajectory today.
Yeah.
And we're not targeting orbit today. We're targeting almost orbit today. That's very intentional as part of the mission design. The goal is to get to a thrust profile similar to what we would need for orbit, but also
And
to
expect
get
the
to
loss
the
of
energy
signal,
levels
Houston.
that the ship would need to dissipate for re-entry. And so we're actually going in a suborbital trajectory today, but that trajectory will get us to the energy levels that we need at re-entry, where we can really stress that heat shield and get valuable data on re-entry. And those calls that we are still on a nominal trajectory here and seeing nominal pressures means that we have a really good shot of hitting our target orbit.
Yeah. Now, if the booster had survived, we would be around the time where it would be getting ready to land, performing its re-entry, but it unfortunately did not survive. That being said, that's okay. It survived several seconds after hot staging, so we're going to take that data and improve the hot staging sequence and probably improve the hardware itself for the next flight.